Okay, so with this video, we're going to talk about the question number 1 of the section A of the Math AA paper 2 AASL exam for time zone 1 of the November 2023. So question number 1, when you see that we have to find the gradient of the tangent or the gradient of the normal line or equation of the normal, right? So that means this question is actually from topic 5, the calculus section of your curriculum. So question AI, we need to find the gradient of the tangent to the graph of the f at the point A, right? So means we first have to identify the derivative of the function f of x. So we get 2x minus 10. Once you've done this, to find the gradient of the tangent, you have to substitute that x value of the point A, which is x4. Then we get f prime for 2 times 4 minus 10, which is same as 8 minus 10. And we can say minus 2 is the gradient of the tangent. Then let's talk about AII. We need to find the gradient of the normal line to the graph of the f at point A. So we already know that if this is a tangent line, the normal line is perpendicular to that tangent line, right? So we know that when we multiply the slope of the tangent line with the slope of the normal line, it is equals to -1, right? Because they are perpendicular to each other. Or we can say that when there are two lines that are perpendicular to each other, their slopes multiply into -1, right? So we can say m1 times m2 equals -1. Then if we say that m1 is the gradient of the tangent line, we can say m1 is same as -2, and m2 is the slope of the normal line. Then it's equal to, when we multiply these two together, it is equal to -1. Then we can say m2 is same as -1 over -2 or 1 over 2. So this is equals to the gradient of normal line. Then question B, we need to write down the equation of the normal to the graph of f at point A, right? So we know that the gradient of the normal is same as 1 over 2. And then point A has the coordinates of the 4, minus 24. Okay, so that's given information. Then using the equation of the line, y minus y1 equals to m times x minus x1, we can substitute this information into this line of the equation, right? Then we get y minus 24 equals to 1 over 2 times x minus 4. Then simplifying this will give us the equation of y plus 24 equals to 1 over 2x minus 2. Then we can say y is same as 1 over 2x minus 2 minus 24. Therefore, the equation of the normal is same as 1 over 2x minus 26. Okay, then let's do question C. So we got more information. So normal to the graph of f at point A intersects the graph of f again at the second point B. We need to find the coordinates of the B, right? So we know that, so this is the question C. So we know that normal line equation is same as y equals 1 over 2x minus 26. And the function f of x is same as x squared minus 10x. Okay, so we are trying to find the intersects. So from topic 2, we did this type of questions. So when you're trying to find the intersects manually, what you need to do is you have to set these two equations equals to each other like this and have to solve for the x. Okay. However, since this is a paper 2 question, we can simply use the GDC. Okay. So let's talk about how to use GDC. So if this is your TI-84 calculator, okay, so on your y equals that, the equation of the graph button or the screen, you're going to substitute your first equation there. So 1 over 2x minus 26. And on your second line of the equation, you're going to substitute your function f of x, so which is x squared minus 10x. Then you're going to graph it. Okay? Then you will see a graph like this, and it is very clear that you have two intersection points, right? And what we are trying to do is we are trying to calculate this second point here. Okay. However, you cannot just calculate like this. You have to use the second car. Okay. So what I did is you have to use second car button and then have to click on the 5 intersect to find your intersection point. So you click on 5, then you will see left bound, right? So you move your left bound line to the left of your second point and hit enter. After that, you move your line again to the right hand side of your second point and hit enter and enter. Then you will see intersection point of x equals 6.5, y equals negative 22.75. However, since you always have to write your answer in specific, you can just write your y value as negative 22.8. And that's the answer of the question C. Okay, then let's try the question number 2. So this question is from topic 3, the 3D geometry section of your curriculum. So if you look at here, we know that we have a point B which has the coordinates of the 8, 6, 0, point C which has the 8, 0, 0, and the point V which has the coordinates of the 4, 3, 10. So question A, we need to find the length of the BV, right? So BV is here. So what you need to do is we're going to use the distance formula. So from your formula booklet, it says that the distance D is same as square root x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. That's the formula in your formula booklet. So with this question, we can do distance equals to 8 minus 4 square plus 6 minus 3 square plus 0 minus 10 square, and say this is equals to 125. So it is approximately equals to 11.1803. However, since we always have to leave our answers in specific, we can say the distance of distance between the point B and V is same as 11.2. Question B, we need to find the size of the B, V, and C. So means we have to find the angle here, right? So let's rewrite this triangle, or let's redraw this triangle here. So this is C to V, and then this is B to V. So we say C, V, and B. And we know that the B has coordinates of the 8, 6, 0, and C has coordinates of the A, 0, 0, right? And the V has coordinates of the 4, 3, 10. So means V is located right in the middle of the line C and B, right? So means these two sides are same. If we are dividing it like this, that means these two sides are also same, right? So that means we have an equatorial triangle. So means since we know the length of between the point B and V is about 11.1803, we know that the length between or the distance between the point C and V is also 11.1803. Okay, and we know that from here to here is about 6, right? Based on the coordinates that's given, right? So because like from here to here refers to the y-axis, right? So this side refers to y-axis, and we know that this graph starts from the 0 and it stops at 6 on the y-axis. So we can say that the distance between the point C and V is 6. Okay, so since that means since we know the three sides of the triangle and then we are trying to find one missing angle, we can use the cosine rule to solve that missing angle, right? So we can use b squared equals to a squared plus c squared minus 2ab times cosine VVC, and we're trying to find this angle here. Then we can substitute all the values. Make sure you use 11.1803 instead of 11.2. Then using your GDC, we can do 6 squared minus 11.1803 squared minus 11.1803 squared, negative 213.99 equals to negative 2 times 11.1803 square cosine VVC. Then cosine VVC is same as minus 2. Let's use the bracket. Minus 2 times 11.803 square. Then we get 0.8559989. Then we can say angle VVC is same as 0.5433. However, since we need to leave our answers in specific, your answer is going to be 0.543.